I'll give you a 1 minute warning.
Hi there, definitely a pleasure to be here. My name is Tadej, and I'm a lead machine learning engineer at Open Capacity. We do smart public transport with the use of AI, but today I'm going to focus on a state-of-the-art NLP library called Flair and give you like a high-level overview of maybe how it works and also how to build models with it. Flair is, again, one of the many NLP libraries, but in many ways it's very different from all the others. It offers most of the usual tools you would expect from a natural language processing library, but the thing I really like about it is that it's super simple. So most of the tasks are usually one-liner or two-liner. So predicting, usually using a pre-trained classifier is a one-liner task, and training a new embedding, for example, is a four-liner task, which I find pretty amazing. And on top of all that, it achieves state-of-the-art results in several natural language processing tasks. It also comes with a few pre-trained models and also a few embeddings like BERT and Elmo, and it also features a few of its own text embeddings, which I'm going to talk about now. So I think this is the secret sauce of the whole package called Flair. And I think the two ways in which it differs to other more conventional word-based embeddings that we use these days is how it treats context and how it's a character-level language model as opposed to a word-level language model. And the way it treats context is interesting because if we use one of the more conventional embedding approaches that people use today, like word-to-vec or glove, for example, we would use pre-computed word vectors for glove, for example, and we would extract an embedding for a particular word, regardless of what context that word is used in, for example. Whereas if we use contextual embeddings, the input of our embedding is actually the whole sentence, and the result is just the embedding for that one word that we're interested in. And based on that, we can generate different embeddings for the same word based on what context it's in. More on that later, but the second really important characteristic about contextual string embeddings is that they're character level based. So usually the input of a word embedding system would be a sequence of words, whereas here we use a sequence of characters. The important thing here is that a sequence of words assumes that we have a predefined vocabulary. So usually we'll have a problem of out of vocabulary words and misspellings and prefixes and new words and imaginary words. And what we usually need to do with these is either just remove it or just replace it with a placeholder. Whereas this character-based approach can work both with misspellings and with new words that just don't happen to be in the vocabulary at a particular moment. So the approach that's proposed in the paper, also implemented in Flair, uses contextual string embeddings with an approach called stacking. So we actually use a combination of several word and character embeddings. So in this example, you can see how word Washington is embedded, and its vector representation is extracted from the whole sentence. So we use a combination of two different embeddings. So the first one is the forward character embedding, which is the red one that uses everything up to the last character of Washington. And then we have the backwards embedding that uses everything from the end of the word until the first word of the word Washington. And then we stack them together, which is just a fancy word for concatenating the embedding vectors. And that would be like a high-level approach of how embeddings are used with Flair. The approach that achieved state-of-the-art results was actually a combination of a forward character language model, backwards character language model, and glove. So this is something we used in our own text classification model that we tried just for fun. It's one of the most straightforward approaches to use. Here, for example, you can see a code snippet on how to train a custom text classification model with Flair. And first, of course, you need to define the corpus, which uses fast text format. So if you use fast text, that should be pretty straightforward. And afterwards, we define the actual stack of word embeddings that we used. So basically a one-liner. Of course, we need to achieve document embeddings to create a document classifier. And for that, we use an LSTM approach that's included in Flair. And with another one-liner, we can then train the model. Here, it's important to note that Flair offers a variety of hyperparameters that we can train if we want. But here, in this example, we just use the default parameters. It also features a hyperparameter optimization library, which is built on top of HyperOpt. So if you've used HyperOpt before, you should definitely be familiar with it. Here's another example of how to use pre-trained text classifiers, another three-liner. So this is everything you need to do to load a sentiment analysis model, which, if I remember correctly, like 2-3 years ago, was a huge task where companies had to pay thousands to do what can now be done in like 3 lines. And now I'm just going to show you like how we can use our own spam ham text classifier that we used. So the usage is really trivial, so but it's still very fun to see it work in production. So we trained the spam ham text classifier that classifies text messages into spam or ham. So we can try something that would be like a free promo, and we would expect this to be spam, for example. And now we can try something that we're not sure about. So, for example, we can I don't know. We can ask like PyData is really cool.
Oh, please be good.
Come over. So you know what to expect here, of course.
Yay! Fix.
And that's it. That was short and sweet. Thank you very much.